In this video, we will learn the last 15 questions from the chapter Electric Field and Potential. The book is Concepts of Physics, Volume 2. Question number 1 to 60 we have seen in 6 different videos containing 10 questions each. The link you can find in the description. In question number 61, it is saying that two charged particles having equal charges 2 into 10 raised to minus 5 coulomb are brought at a distance of 10 cm from infinitive. Find the increase in electric potential energy. We know that the formula of electric potential energy is 1 by 4 pi epsilon naught q1 q2 upon r, or k q1 q2 upon r. q1 is given 2 into 10 raised to minus 5, q2 is given similar value 2 into 10 raised to minus 5, and the distance 10 centimeter, we can take 0.1 meter. After calculation, like 9 into 2 into 2, it will be 36. 10 raised to 9 into 10 raised to minus 10 upon 0.1. So it will be 1 only, because 0.1 is 10 raised to minus 1 will go up, it will be 10 raised to plus 1, added with the 10 raised to 9, it will be 10 raised to 10, and that would be added with the 10 raised to minus 10, it will be 10 raised to 0, and the value will be 1. So answer will be 36 joule when they are carried from infinitive to a distance of 10 centimeter. Question number 62, saying some equipotential surfaces are shown in figure. You can see there are two diagrams. Let us deal about the first diagram first. The equipotential surface, it is given at an angle 30 degree with the x-axis, and the distance from the origin is 10 centimeter, 20 centimeter, 30 centimeter, 40 centimeter. Voltage is given 10 volt, 20 volt, 30 volt, 40 volt. We have to calculate what is the electric field over there. We know that electric field is always perpendicular to the equipotential surface. So E is equal to, if we take the relation minus dV upon dr, we can write dV is equal to E dot dr, and dot product of two vectors are A, B cos theta. So dV is equal to E dr cos theta, or E is equal to minus dV upon dr cos theta. If you talk about angle here, it is nothing but 120 degree with x-axis, 30 degree plus 90 degree. So if you take 120 degree, 120 value is negative half. So after simplifying this calculation, the electric field would be 200 volt per meter at an angle 120 degree with the x-axis. So that is the answer for part A. When we talk about B, the equipotential surfaces are taken in concentric spherical. It means there will be some point charge present at the center, and you can see 60 volt, 40 volt, 20 volt, this potential is decreasing. It means charge would be positive in nature. Anyhow, be there as may, we are not going to find the sign of charge, rather we are going to find the electric field. So here again electric field would be perpendicular to the equipotential surface. You can see the direction. E is perpendicular at every point, so it means it will be radially outward. Direction is fixed, that is radially outward, and radius is perpendicular at any point on the surface of sphere or at any point on the circumference of a ring or circular shape. So that we know E is perpendicular already. We know the potential formula is kq upon r, and potential, if we take at a distance of 10 centimeter, it is given already 60 volt. So if we take 60 volt, kq upon distance is 10 centimeter, we will change into meter. Kq is coming as 6. So q is equal to how much? 6 upon k. This particular value we are going to use to get the electric field at a distance of r from the center. So that we will be using kq upon r square, simple formula, because of a point charge, this is the field. Then q value we will be taking 6 upon k. So k would get cancelled, and the electric field would come as 6 upon r square. R is different for the first equipotential surface, for the second equipotential surface, for the third equipotential surface, because electric field here is going to change as we increase the distance. So electric field is nothing but 6 upon r square. If you want to find a 10 centimeter, it will be 6 upon 0.1 the whole square. If you want to find it 20 centimeter, same value, you can put r is equal to 20, change into meter, and it will be radially outward. That was the solution of question number 62. 63 is saying that consider a circular ring of radius r uniformly charged with linear charge density lambda. Lambda means charge present per unit length. If you talk about this situation, circumference total of this ring will be 2 pi r. So lambda is equal to q upon 2 pi r, or q is equal to lambda into 2 pi r. So find the electric potential at the point on the axis or at a distance x from the center of the ring. Using this expression for the potential, find the electric field at this point. So this is the axis. At x, at a particular distance x, we are going to consider point P, and it will be at a distance from any point on its circumference under root r square plus x square. This value we are going to consider as z. Later on we can replace z by under root r square plus x square. Now lambda is equal to q upon 2 pi r, as I said. So q is equal to lambda into 2 pi r. Voltage formula we know already, 1 by 4 pi epsilon naught q upon distance. So if we take a particular charge particle q at a distance z, the voltage will be 1 by 4 pi epsilon naught q upon z. Q we are going to replace by lambda into 2 pi r upon z, and the formula will be, if we replace z by its real value, it will be 1 by 2 epsilon naught lambda r upon r square plus x square power half. This is the formula of voltage. Now if we want to find the electric field, for that we know that at that particular point electric field is always cosine component of total field, because two objects or two small charge elements we are going to consider diametrically opposite points, it will be producing two fields, and both the fields would be having two rectangular components. One rectangular component as cosine would be in same direction from both, but from both sine rectangular components are going to cancel each other. So E cos theta is equal to V by Z, as the relation E is equal to voltage upon distance, and then we can take the value of V here, 1 by 2 epsilon naught lambda r by z upon z cos theta. Cos theta value again we are going to take x upon z, and z value now we are going to put finally. So electric field formula would be 1 by 2 epsilon naught lambda rx upon r square plus x square power 3 by 2. Question number 64. There are two plates, one is positive, one is negative, and between these two plates electric field intensity is given 1000 Newton per coulomb, and the distance between the plates is 2 centimeter. Question number 1 is, what is the potential difference between the plates? So we know that voltage is equal to E into D, or E is equal to V by D, simple formula, the relation between voltage and electric field. So voltage is equal to electric field into distance between the plates, 2 centimeter. If we are changing 2 centimeter into meter, it will be 2 into 10 raised to minus 2 meter, and then after simplifying it will be 20 volt. B part is asking, with what minimum speed should an electron be projected from the lower plate? We know that lower plate is positive, and the electric field is there from positive to negative. If we are going to project a particular electron from positive towards negative, it will be retarded by the course of time. It is going to be stopped finally, because negative plate is going to repel. Positive plate from which we have been throwing or projecting that particular electron, the question is related to that, be projected from the lower plate in the direction of the field so that it may reach the upper plate. It may reach the upper plate. It means we need to calculate the initial speed when it is going to travel a distance of 2 centimeter inside the electric field, retarding by some retardation. That retardation will be ma is equal to force on electron, that is QE upon m. So acceleration is equal to QE upon m. Q is electronic charge, E is electric field, m is mass of electron. If we simplify this, acceleration will be retardation will be 1.75 into 10 raised to 14 meter per second square. Now we are using simple formula of kinematics. That formula is u square minus 2as is equal to v square. Negative I have taken because it is the case of retardation. Electron is traveling in the direction of electric field or projected in the direction of electric field, so it would retard it. It would be retarded because the force is acting in a direction opposite to its initial motion. Okay, so v square final velocity would be 0 because somehow it had to reach over there. Initial velocity we have to calculate, minus 2 into acceleration into s, that is 2 centimeter. Once we simplify, we will be getting u square is equal to 7 into 10 raised to 12 meter per second, or 2.64, that is root under 7, so 2.64, and 10 raised to 12 under root, it will be 10 raised to 6 meter per second. With this minimum speed, if we are going to project the electron, it would reach to the second plate. C part in the question is being asked, suppose the electron is projected from the lower plate with a speed calculated in part B. The direction of projection makes an angle 60 degree. Now if you see this, it is the case of simple inclined projectile motion. 60 degree with the field, find the maximum height reached by the electron. So in projectile motion, which we have learned in 11th standard, the formula of height attained is u square cos square theta upon 2a. It is actually 2g, but here acceleration is 2a because we have to neglect the acceleration due to gravity. There the acceleration is actually retardation, which has been developed in part B, 1.75 into 10 raised to 14 meter per second square. So if we put all the values, we will be getting a height 50 centimeter. So it will be reaching maximum height of 50 centimeter. In question number 65, it is saying that a uniform field of 2 Newton per coulomb exists in space in x direction. The electric field is given along x-axis. It means this E is equal to, we can write 2I Newton per coulomb. Part A is asking, taking the potential at origin to be 0, write an expression for the potential at general point x, y, z. Let us take general point x, y, z. So we are knowing that the dV is equal to minus E dot dr. So dV is equal to, for x we can write minus Ex dx minus Ey dy for y, and for z obviously it will be minus Ez dz. But electric field is given along x-axis only. So it would be like V origin minus V infinitive is equal to minus 2, that is Ex into dx would be x on integrating it, or if you are taking distance as x. Ey dy Ez dz would be negligible over here. Now at infinitive electric potential is given 0, so at origin it will be minus 2x. That is the expression we can use. Now B part, at which point the potential is 25 volt. So let us take again V0 or V1 minus V2 is equal to minus 2x. So x is equal to 25 upon 2, that would be 12.5 meter, or V final minus V initial you can take. So C part is asking in the question, if the potential at the origin is taken to be 100 volt, what will be the expression for the potential at general point? So Vp minus 100, general point we can take P, so Vp minus 100 is equal to minus 2x as per the relation in A, and then Vp is equal to 100 minus 2x, that would be the relation. If x is known, you can find the potential at any point. Part D in the question is asking, what will be the potential at the origin if the potential at infinity is taken to be 0? Is it practical to choose the potential at infinity to be 0? So the question is, what will be the potential at the origin if the potential at infinity is taken to be 0? It will be just reverse, because we consider that at infinity potential is 0. At origin we can find the value, required value. If we are going to take ourselves to infinitive, origin would be infinity for us. So obviously D point is going to be infinitive as answer. Question number 66 is the question being asked that how much work has to be done in assembling three charges particle at the vertices of an equilateral triangle as shown in figure. In the diagram you can see each side is 0.1 meter or 10 centimeter. Q1 is 2 into 10 raised to minus 5, Q2 is 3 into 10 raised to minus 5 and Q2 is 3 into 10 raised to minus 5 and Q3 is 4 into 10 raised to minus 5. If I ask how many pairs of charge is present over here? So charge is present here in three pairs. Which one? This one, second one, and the third one. So if we can calculate what is the potential energy in each pair, then we can add them. That will be the total work done, because work done is nothing but equal to potential energy. So let us now calculate the potential energy of whole system taking three pairs of the charges present in on the vertices of an equilateral triangle. So here 1 by 4 pi epsilon naught or k q1 q2 upon r. For second one it will be k q2 q3 upon r, then k q3 q1 upon r, r because it is 0.1 meter each. K upon r will take common and then it will be added q1 q2 q2 q3 plus q3 q1. Put all the values, 9 into 10 raised to 9 upon 0.1. If you see here 10 raised to minus 5 and 10 raised to minus 5, that 10 raised to minus 10 would be common. Then what is left? 2 into 3 plus 3 into 4 plus 4 into 2. If you are going to add them, it will be 26. So 9 into 26, nothing but 234 joule is the total work done in assembling these three charges on the vertices of an equilateral triangle of size 0.1 meter. The question number 67, the kinetic energy of a charged particle decreased by 10 joule as it moves from potential of 100 volt to a potential of 200 volt. Find the charge on the particle. We have one formula that change in potential is equal to work done upon charge. This work done is nothing but decrease or increase in kinetic energy we can take. So V2 minus V1 is equal to kinetic energy upon charge. V2 minus V1 is nothing but 200 minus 100. So charge is equal to change in kinetic energy upon 100. That is decrease, so minus 10, and it will be minus 0.1 coulomb. The value of charge we have calculated. Question number 68, two identical particles each having a charge of 2 into 10 raised to minus 4 coulomb and mass of 10 gram are kept at a separation of 10 centimeter and then released. What would be the speed of particles when the separation becomes large? See, why the speed is going to be gained by the particle? If we are taking this one charged particle 2 into 10 raised to minus 4, another charged particle 2 into 10 raised to minus 4 coulomb, and the distance is given 0.1 meter, there will be force of repulsion between these two. That force of repulsion, once we are going to release them at a distance of 0.1 meter, they will be repelling each other, so they will move away. So what we can do to calculate the value of speed, we can calculate total energy at 0.1 meter and then total energy or total kinetic energy just after releasing them, because potential energy between these two is going to be appear as kinetic energy. So here if we are taking initial potential energy, it is k q1 q2 upon r and the value will be 36 into 10 raised to 2 joule. Now we know that the change in energy or change in potential energy is nothing but the energy appeared in both as kinetic energy. So we have taken half mv square plus half mv square. So u initial minus u final is equal to half mv square, it will be only mv square. U final will be 0 because we don't know at what point maximum distance means, maybe infinity. So that will be 0. 3600 already we have calculated here, mv square. Then v square is equal to 3600 upon 10 raised to minus 2. It will be 36, 4 times 0, and v is equal to 600 meter per second. So once we release them at a distance of 10 centimeter, it will be gaining a speed of 600 meter per second. Question number 69. Two particles have equal masses of 5 gram each and opposite charges 4 into 10 raised to minus 5 minus 4 into 10 raised to minus 5. They are released from rest at a separation of 1 meter between them. Find the speeds of particles when the separation is reduced to 50 centimeter. In this question, two charged particles are already kept at 1 meter. Look at the diagram. 4 and minus 4 into 10 raised to minus 5. Distance is 1 meter. Now they are being released. Released means because of force of attraction they will be moving towards each other. In the previous question it was because of force of repulsion they were moving away from each other. They will be moving towards each other. Now the question is, find the speeds of the particles when the separation is reduced to 50 centimeter. Separation is being reduced to 50 centimeter means what? From both the sides, these charged particles has to move towards each other by 25 centimeter. So if they are going to move by 25 centimeter, the remaining distance would be 50 centimeter or 0.5 meter. At this distance and at previous distance, we can actually apply the conservation of mechanical energy. What is conservation of mechanical energy? The total energy means kinetic energy plus potential energy of a system remains unchanged, remains constant, isolated system rather, because external force is not being applied on both of the charges over here. So K initial plus U initial, that kinetic energy plus potential energy initially is equal to kinetic energy plus potential energy finally. And then initially there was no speed when they were kept at a distance of 1 meter, so it will be 0, but potential energy obviously will be there, K Q1 Q2 upon R1, that is 1 meter. K final half mv square plus half mv square, both the particles having same mass, so they would be achieving the same speed because they are being attracted by the same amount of force. Then at a distance of half meter, what is the potential energy? K Q1 Q2 upon half meter. So if we are taking this potential energy one sided and mv square one side, after putting the value of R, we are getting mv square is equal to K Q1 Q2 into 2 minus 1, because one place we have taken distance half meter, at one place we have taken 1 meter. If we put all the values, we are getting mv square is equal to 14.4. Now m is given 5 gram, so v square is equal to 14.4 upon m, that is 5 into 10 raised to minus 3 kg. We try to simplify it more, and then the value of v which we are going to get is root over 144, it will be 12, root under 20, it is nothing but 4.47. After multiplying, it will be around 54 meter per second or 53.64 meter per second to be more precise. So this was question number 69. Let us see question number 70. A sample of HCl gas is placed in an electric field. HCl, if we know, it is H plus C minus. It would behave like as an electric dipole. Distance, if it is given, even not given, dipole moment would be given in the question. The question is placed in electric field 2.5 into 10 raised to 4 Newton per coulomb. The dipole moment of each HCl, that P is given 3 into 10 raised to minus 30 coulomb meter. Find the maximum torque. If we talk about torque, the maximum torque is PE, because torque formula is PE sin theta, and torque would be maximum when theta is maximum and sin theta maximum at 90 degree, it is 1. P is dipole moment, E is electric field. So once we multiply this P E sin 91, we will be getting 8.5 into 10 raised to minus 26 Newton meter as maximum torque on the HCl molecule. 71. Two particles A and B having opposite charges 2 and minus 2, 10 raised to minus 6. are placed at a separation 1 centimeter. First, write down the electric dipole moment of the pair. We know that electric dipole moment formula is any one charge into distance between charges. So any one charge is 2 into 10 raised to minus 6 and distance is given 1 centimeter. So 10 raised to minus 2 meter. It will be 2 into 10 raised to minus 8 coulomb meter. B part, it is being asked calculate the electric field at a point on the axis of the dipole 1 meter away from the center. At the axis if we talk, on the axis if we talk, it is nothing but field at equatorial or field at end-on position, and for that formula is 1 by 4 pi epsilon naught 2p upon r cube. P is again from A we can take the value of P, it is nothing but dipole moment. So if we put all the values, it will be 360 Newton per coulomb after calculation. In part C, it is being asked calculate the electric field at a point on perpendicular bisector. Perpendicular bisector field is just half to that of equatorial, sorry not equatorial, to axial electric field or electric field at end-on position. So we can even directly write 180 Newton per coulomb, or formula wise if E is equal to Kp upon R cube, it is 9 into 10 raised to 9, 2 into 10 raised to minus 8 upon 1 cube, and it is nothing but 180 Newton per coulomb. Question number 72 actually is saying 3 charges are arranged on the vertices of an equilateral triangle as shown in figure. Find the dipole moment of the combination. Actually in the figure it is given like this. Charge amount is minus q and this is 2q and the distance is given d. So if it is equilateral triangle, distance between any two pairs of charges, it will be d only. Now if q we are going to take as q plus q and plus q, because dipole by definition it should be having equal and opposite charges placed at small separation. So this 2q we can consider as q and q, so that between two pairs the dipole moment will be from negative to positive as p is equal to q into d, and from here also it will be q into d, and they will be at an angle 60 degree because of equilateral triangle. If we want to calculate net p, we have to add these two vectors when they are inclined at an angle 60 degree. So this will be the resultant 30 degree from both. But what is the magnitude of resultant? So we have already p is equal to q into d, and there are 2p inclined at an angle 60 degree. So resultant formula is under root first vector square plus second vector square plus 2 into first vector into second vector cos theta. So we have written p square plus 2p p cos 60 degree. Cos 60 value is 1 by 2. So 2 gets cancelled, it will be p square plus p square plus p square, that is 3p square, or p would be coming out, it will be root 3p. Now p value is what? Q into d, and that is the final answer. And the direction obviously it will be along the bisector of the triangle at an angle how much degree? 30 degree from any of the dipole moment due to individual pair, and away because it is positive charge, we are getting at the positive charge, and the dipole moment direction is opposite to the electric field, that is towards positive or from negative to positive. Question number 73, find the magnitude of electric field at the point P in the configuration shown in figure when D is much greater than A. Take P is equal to Q into 2A. First diagram, we have to find electric field. Look at the point where Q is present and look at the point where we have to find the electric field. It is nothing but field due to a point charge, and the formula we have as E is equal to 1 by 4 pi epsilon naught Q upon distance square, distance is given D, and obviously it will be away from the charge if charge is positive, this is the value. In B part, the diagram is given like this. and the point is present at the perpendicular bisector of the so-called dipole, which is given in the diagram. So we know that field due to negative charge would be towards, due to positive would be away. Each field would be having two rectangular components. So if field is splitted into two rectangular components, this field would not be having any existence now here, and this opposite components also would get cancelled by each other. So now the component of field which is parallel to the dipole or axis of dipole would we have to calculate actually. So that would be present as e cos theta plus e cos theta, already we have done in theory part, 2e cos theta. After calculation, it is nothing but field at equatorial line position, and it is 1 by 4 pi epsilon naught p upon distance cube. So that distance is given over there. Because a, we can actually write d square plus a square whole power 3 by 2. But in the question itself, it is saying d is much greater than a, so a we can neglect and we can write the formula directly. In part C, apart from if we compare the B to C, one more charge is kept at the midpoint of the line joining the charges. So first value we can take from B, second value we can take from A, and the both will be perpendicular, because if we see in the first diagram it is outward, the second diagram it is parallel to the axis, so net will be in this direction. That net would be calculated as under root first vector square plus second vector square. So 1 by 4 pi epsilon naught will be keeping out, q upon d square plus p upon dq. D square again we can take common, so it will be q square d square plus p square, and that is the electric field at that particular point for diagram C. In question number 74, it is saying that there are two charged particles plus q and minus q having equal masses m are fixed at the ends of a light rod of length a from and form a dipole. So there is a rod, length is a, and plus q and minus q having same masses are connected or kept at both the ends of a rod, and they are forming a dipole. The rod is clamped at an end and is placed in a uniform electric field. This is electric field and one end is fixed. Now the question is, the rod is slightly tilted. Slightly tilted means what? If it is kept in the present direction, you can see in the diagram, there will not be any torque experienced by the dipole, or net force also will be 0, because equal and opposite forces will be acting at the same point of action. But if slightly tilted means the point of action where the force due to both are going to act, these forces will be now acting at two different points. So they will result certain acceleration, and because of that the dipole or the rod would start small oscillatory motion. So the question is, what is the time period of that small oscillation over there? So this is the situation, slightly tilted, one end is fixed, what will happen after that? So let us first calculate what is the acceleration. Acceleration is nothing but qv by m. Why we are calculating acceleration? Because this a distance which is given, don't get confused here, one a is acceleration, one a is distance. So a distance is given, that would serve as the length of the string of simple harmonic motion in the simple pendulum. So if this is a length and this a is serving as acceleration due to gravity as g, we can apply the formula as 2 pi under root L upon g. So L is a, g is qv by m. If we put the value in the formula, it will be t is equal to 2 pi ma upon qe. Here a is not acceleration, rather it is length of the rod which is serving as the length of the string in oscillatory motion. So this was the time period, t is equal to 2 pi under root ma upon qe. I reiterate this, that a is length, not acceleration over here. Question number 75, assume that each atom in a copper wire contributes one free electron. Estimate the number of free electrons in a copper wire having a mass of 6.4 gram. See, atomic weight is given 64 gram per mole. The number of mole, if you want to calculate, the formula is weight given upon atomic weight. So weight given is 6.4 gram, atomic weight is 64, it will be 0.1 mole, and we know that 1 mole of any atom, any molecule contains the number of atom or molecules as 6.023 into 10 raised to 23, that is Avogadro's number. So multiply by 0.1, it will be 6.023 into 10 raised to 22, and one copper contains one electron as per given in the question. Assume that each atom in a copper wire contributes one electron. So what is the total number of electron? You multiply by 1 and the number is 6.023 into 10 raised to 22 electrons. Thanks for watching.